Thank you, Paavo and Sini, for the introduction, and also Dave for the story of the cup. I'm a principal research chemist here at Tactotek. I have worked for the company for 3 years, and during those years we have been developing quite a lot of things and doing a lot of testing. I will concentrate on the functional inks and from them mainly for the silver inks. And I will tell you a little bit about the history of how we have ended up with this universal test layout which is going around. And as Paavo already mentioned, when the company was founded, there was an idea, and the company was based on the founders' ideas. And there's nothing more powerful in the world than an idea whose time has come. So this is why, or this is probably part of the reason why Tactotek is going forward. And for the silver inks, the quite natural selection where the kind of like the background where the printed silvers is coming from the membrane switch industry, where the silver inks have been printed for a long time. But with the membrane switch, there isn't very much of thermoforming or extreme shapes where the inks needs to go. And in Tactotek process, we have a lot of variation, and we kind of take to the next step from the membrane switch. And we needed, it was quite obvious at the beginning that we needed to do studies of the inks, how they print for the silvers, the conductivity of the silver inks, how do they thermoform, how do they perform during the thermoforming. For the dielectrics, how is the insulation strength, how is the printability of the dielectrics. And then we need also to study the stacks. And by stacks I mean that we have the film, graphic ink, silver, dielectric, components, injection molding resins. So this is also plays an important role in our processes. And as you can see from the picture, this is an old layout. And this is the kind of like the first layout where we started to study the silver inks and their printability. There is a lot of different shapes, wide and narrow traces, different orientation of the trace. So this is an excellent layout for testing how is the printing and what is the printability of different silver inks. However, this layout don't have the graphic inks or the thermoforming included. But this was the first where we started to evaluate how the printing of the silvers are. And then when we had the foundations, we did the first tool so that we can study the thermoforming, and this also includes the graphic inks underneath the silvers so that we can see the effects. And this study was more concentrated on the curing and the effect of the curing of the silvers to the thermoformability of the silver inks. And then when we moved on, our designs got more and more complex. We needed to use more and more dielectrics. And then, of course, we needed to study how the dielectrics will perform. And Dave taught us the short and easy Finnish word. So for this, the layout is called eristetestileiska, which is like the which means that this is the layout for studying the dielectrics. And this one has a lot of different dielectrics in the different places. They are under the buttons where the shapes are quite extreme. And then there is a long dielectric traces on some of the forming areas and also on the quite flat areas, so that we will see how does it work. And this tool or this layout also had the graphic ink, and it was injection molded. So this would go through all the processing steps. It doesn't include the component mounting. And with this tool, since we had quite a lot of traces going parallel to each other. Sorry.
Tricky button.
Yes. So for that layout, we could see when we had the traces parallel to each other, that the black color has an effect to the dielectric strength of the dielectrics. And that is, or what we were thinking about, that this is probably due to that the black colors are usually made from the carbon black. So there is a small amount of conductivity, and that affects the dielectric strength. But that is not the dielectric property, it's more of the property of the color. And then we came up with the universal test layout. So this one includes the graphic layers, silver ink layers, dielectrics, the printability with the narrow and wider traces, and they go over the quite an extreme shape, which you can see. And with this, we also included the component attachment. And the components are also attached to the areas which are thermoformed, so that we can study the adhesives that is used for the component attachments. So this pretty much includes all the kind of like the processing steps what we have, and we can study them in one layout. And what we have done, we have tested a lot of silver inks, over 40. We have tested a lot of different dielectrics, and the dielectrics comes always in a pair with the silver inks. We have studied 5 different graphic ink families that includes different colors, 15 different adhesives for the component attachment, and various matrices of materials with the different graphic inks, silvers, dielectrics, the adhesives for the components. And with all the studies that we have made, we have came with the values that we would like to have with the silver inks. And for the silver inks, we have divided the silvers into 2 different categories. The high conductivity silvers and then the high elongation silvers. The high conductivity silvers are mainly targeted for the antenna applications, where the high conductivity is very important. And then the high elongation inks are the ones we would like to make the circuits with, so that we can go over all the possible shapes what we need. And then the dielectrics, we have the crossover resistance what we would like to see. And with this, we don't have the elongation properties for dielectrics, that's quite low. But the more elongation we can have on the dielectrics, the easier it is for our designers to do all the designs. Thank you.